Now I'm going to give you an example of how you can put calculus to use. So suppose you have a function f of x equals x squared here, and you want to find out the gradient. Well, it could be anywhere on this line here. You could find out the gradient at this point, at this point, at this point. It could be anywhere. Let's just say we want to find out the gradient at A. Now the gradient at A would be the tangent line that just touches A. So this here, the gradient of this line here would be the gradient at A. But the thing is, for us to find out the gradient at A, we have to select another point on that line here, and then slowly get this point B here, slowly get the point B here, slowly get B to move towards A, and as it heads towards A, it will then give you the true gradient. Okay, well currently the gradient that exists between A and B is given by this. So the height here would be this bit here, and then, well, to find out the gradient, you always get the height divided by the across here. The across here is h. So currently, oh, by the way, for us to get B to move closer and closer towards A, the way we do that is to decrease h each time. So our aim is to make h smaller and smaller. So currently, h is from this distance here. If we can decrease h each time, it will give the effect that B is moving towards A. You see, if you decrease h, then the triangle gets smaller and smaller each time. You see, hang on. So currently h is here. Oops. Currently h is this length here. So we are using this triangle. If you decrease h, let's say from here to here, then B would be here. If you make h to be really small, then B is moving towards here. And then as you make h smaller and smaller, you would give the impression that that B is moving closer and closer towards A. Well, currently the gradient that exists between A and B is given by this. But you see, the gradient that exists between A and B is not the true gradient. You see, for you to get the true gradient, you will have to get h to head towards 0. You have to keep on decreasing h. So currently the gradient that exists between A and B is given by this. But in order for you to get to the true gradient, you need to decrease h. So decrease h to get h to tend towards 0. So in order, well, currently the gradient that exists between A and B is given by this. Okay, so for you to get the true gradient, you need to take the limit of this whole thing here. So basically, get h to head towards 0. Okay, so yeah, let me just repeat it one more time. Sorry, currently the gradient that exists between A and B is given by this. But in order for you to get the true gradient at A, the true gradient equals the limit of this whole thing here as h tends to 0. Okay, so basically, looking at this diagram, you would need to get h to be smaller and smaller and smaller until it approaches 0. Okay, so the true gradient is given by this. Now, currently our function is this: f of x equals x squared. You see, if you put this into the x here, it would be this. So my point here is that if you look at our original diagram here, currently this point here is x plus h. So when you put this value here into our function, currently our function is this, x squared here. If you put this into the x squared here, it will immediately give you this point here, this height here. Okay, so hang on. So we started out by saying that the gradient between A and B is given by this. But the true gradient would be when you take the limit as h tends to 0. Okay, but currently our function is this: f of x equals x squared. So we're going to put this point here, we're going to put this into here. So that's going to be, so this thing here squared. So that's this bubble here squared. Okay, and f of x is just, remember, f of x is just sorry, f of x is x sorry, f of x is x squared. So this f of x here is this bit here. What I'm trying to say is that if you look at the diagram, hang on, this take away this would give you this length here. Would give you this length here. Okay. Yeah. If you put this into the function f of x squared here. So basically, put this into here. That will give you the whole length here. Don't forget this height here is x squared. Okay, so it's really you getting this whole length here. Take away this length here. Take away this length here. Then what's left will be the height of the triangle. Okay, so hang on. So the true gradient is given by this here, and then we then put this into the f of x. We then put this into the f of x here, which is x squared here. Put this into here, and then it will give you this, and this f of x is just x squared here. So that would be that divided by h. Now and then the trick here is to multiply this out. So visualize this bit here as this x plus h, and then times it by itself. So you're going to get x times x. So that will give you x squared, and then x times this, and then this times this. That will give you 2xh, and then you've got h times h here. That will give you h squared, and then let's just take this down here. Okay, so multiply this out will give you this whole thing here. Okay, and then you can see that these two will cancel out. Here you've got, well, these two will cancel out. Okay, that will give you this, and then you can factor out the h, because you've got, if you look at this here, this, and so you've got this block plus this block here. H is in common, h is in common, so you can factor out the h. Okay, so it will become this, and then you can cancel out. Well, these two will kill off each other, leaving you this. Now the thing is, when you take the limit as h tends to 0, then this thing here will disappear, leaving you the true gradient. True gradient equals 2x squared. Sorry, 2x. The true gradient equals 2x. So when you look at this here, this is our function f of x. F of x equals x squared. But when we looked, when we just worked out that the true gradient, hang on, the true gradient equals 2x. That means this is our gradient. This is our gradient graph, if you like. So let's say if you look at this here, if you want to know the gradient at this point here, which is x equals 0 here, and you can see that the gradient here is 0 because it's flat. Now, don't forget, this is our true gradient graph, if you like. When x equals 0 here, you can see that the gradient, remember this is a graph of, let's say, x and a graph of true gradient. Okay? Hang on. So when x equals 0, you can see that the true gradient is 0. Now, if you look at this here, let's say you want to find out this point here at x equals minus 1. What is the gradient of this graph? What is the gradient of this graph at x equals minus 1? So you would draw a tangent line looking something like this. So you can see the gradient is a negative gradient. So now jump to our gradient. Remember, this is 2x, okay? This is a line of 2x. So when x equals minus 1, the gradient, so you would go down here, you can see that the gradient is a negative gradient, and it's minus 2. So this here, you can see is a negative gradient, and the gradient's actually a negative, it has a gradient of negative 2. So if you look at, let's say, this point here, whatever this point here is, hang on, let's clear this. Let's say you want to find out this point here. What is the gradient at this point? So you can see the gradient is quite steep, and it's a positive gradient. Let's say this point here is 1.5. Okay, so So x equals 1.5. Now go. Oops, sorry. Hang on. So we want to find out the gradient at this point here, which is when x equals 1.5. Okay. The gradient at this point here. Well, jump to your. We just worked out that the gradient is 2x. So at 1.5, which is here, the gradient here will be positive 3. So going back here, the gradient at this point here is positive 3. Okay, even if you're here, you can see that when you're up here, it's really steep and it's negatively steep. So looking at the gradient graph, you can see if x is it's going to be really steep and it's negatively steep. So as you move outwards out here, then you can see that the gradient will be really steep, but negatively steep. And then as you head towards here, you can see that it's getting shallower, but it's still negative. So looking at the gradient graph, you can see that, well, you can see that it's you can see that it's getting shallower and shallower, but on the left hand side it's negative. So looking at this thing here, on the left hand side here, the gradient on the left hand side is negative, and then as you move to the right hand side, you can see the gradient's positive. So looking at the gradient graph, you can see on the right hand side, it's all positive, and then the further you move out, the steeper it becomes. So the further you move out, the steeper it becomes. That's why when you look at the gradient graph, the further you move out to the right, the steeper it becomes. The higher this thing here will become. So the gradient increases as you move. Well, I will elaborate more on this. I will give you another example in the next video. Okay.